So these are talking about solving systems of equations by graphing. So if we'll remember, a system of equations is any time that you have two equations together, and sometimes you see this little bracket between them putting them together. So the first set of notes right now, it says solve by graphing, but really it's just checking to see, can you tell whether or not a given point, so an XY coordinate point, is a solution to a system of equations. So to check to see if an ordered pair is a solution, you take the 1 and plug that into the x value, and plug the 9 and plug it into the y value. So you're going to plug them into the first equation. Well, in this case, when I plug in 1 and 9, 1 plus 9 equals 10, 10 equals 10, perfect, it works out. That checks out in one of the equations, but it doesn't mean that it's a solution to both equations. So I've got to go back in and plug the 1 and the 9 into the other equation. So 3 times 1 plus 9, 3 plus 9, does it equal 12? Sure enough, 12 does equal 12. So what that means is, because it works in both of them, that this ordered pair makes both systems true, or both equations true, so 1, 9 is a solution of the system. Alright, so the next one is tell whether the point 2, 3 is a solution of x plus y equals 5 and 2x plus 5y equals negative 11. So we're going to substitute the 2 and the negative 3 into one of the equations. I'm just going to put it into the first one. 2 plus negative 3 equals 5. Well, negative 1 doesn't equal 5. There's no need to even check the other equation, because you're done. If it doesn't work for one of them, it doesn't work for either one. So in the examples that they give you in the problems, alright, what I did is I looked here and I said, okay, that's 0 and negative 4, so I'm going to plug in 0 and I'm going to plug in negative 4. 2 times negative 4 is negative 8, so negative 8 does in fact equal negative 8. That first one works out just fine. When I plug in 0, 4 for x and y, it doesn't matter that the x and y are not on the same side. You just plug it in and see if it's true. And what we get when we plug in that one, let me grab my other pen. Alright, we get 0 equals 4 plus negative 4. Well, 4 plus negative 4 is 0, so 0 equals 0. So yes, that one works out for sure. So yes, this is a solution. In this next problem, it asked me to plug in 2 and 5. So I plug it into that top one. 2 plus 5 equals 7. Well, 7 is what 2 plus 5 is, so that works out. So then I plug in 2 and 5 into this equation. So 3 times 2 plus 5 equals 10. Well, 3 times 2 is 6 plus 5. And it's supposed to equal 10. Well, that's not true at all. 6 plus 5 equals 11. So let's take a look at what we're going to do with the problem number 3. So in place of the x and the y, I'm going to put in negative 3 and 1. So just below this line, I'll do my work. So I get 2 times negative 3 plus 1 equals 5. So 2 times negative 3 is negative 6 plus 1 equals 5. Well, negative 6 plus 1 is negative 5 equals 5. Well, even though they're both 5s, one's negative and the other one's positive, I can stop right there. No, it is not a solution. And then in my last problem, I'm going to plug in 9 for y and negative 3 for x. So I'm going to say 9 equals negative 3 plus 12. 9 equals 9. Alright, so that first one works. Alright, so now I'm going to check my other one. My other one is supposed to be 9 equals, and then that's supposed to be negative 3 times, and I plug in negative 3. Because negative 3 times negative 3 is a positive, I get 9 equals 9. It works out. So yes, because it works in both equations, this works. This is why when you get an answer to a system of equations problem, you have to plug it into both. A lot of mistakes were made when it was plugged into just one and it worked. Up here you can see it worked for one, but it doesn't work for the other. So if you were checking your work and you just picked this equation, had you found the answer, then you would have said, oh, it checked out, it's right. Well, it wasn't right, so you've got to check it in both equations. So to solve the system by graphing, truly by graphing, this one says check to see if it is a solution. So what they did is they decided to graph both of these lines. They're both in y equals mx plus b form, so it's very quick to graph. So when I take a look and I graph the two lines, and it's asking to see if 5, 7 is a solution. Well, I go over 5 and up to 7, and that is a point on one of the lines, but it's not where the lines meet. So that's not a solution at all. The solution is where the two lines cross. So in this case, the solution is at negative 1, 1, because that's the point where the two lines cross. So find the solution of the graph lines below. You just go over to where it crosses, and in this case, it was at this point, which was at negative 1, positive 3, so my solution's at negative 1, positive 3. So if I take a look right here, where they cross is the solution. So to get over to that, the x value is at positive 2, because I'm going to just follow it straight up, and that's at positive 2. And then I'm going to follow it straight over here, and it's at negative 3. So the solution to the system of equations is at 2, negative 3. So for number 7 and 8, it wants you to actually graph them. So y equals negative 3, that's a straight line. The y equals lines, or lines that go left to right, are horizontal lines. So at negative 3, I draw a line left to right. And that's the graph of y equals negative 3. If this were x equals negative 3, I would go over to where x equals negative 3 and draw a line straight up and down that goes through that. But because it's y, I know it goes left to right. Then the next line is y equals x plus 2. So I'm going to start over here at 2, and my slope would be 1 because it's right in front of the x. So I'm going to go to the right one, up 1, right one, up 1, right one, up 1. It's a positive slope, so a positive over a positive. Or I could go left 1, down 1, because that's a negative direction over a negative direction. And I drew the line, and I look to see where they cross, which is this point right here. If I go up from there, that's at the point x value of negative 5. And if I go to the right from here, that's at the y value negative 3. So for the last one, it's at y equals x minus 6. So I'm going to come down here to minus 6, and I'm going to put a dot. And then it's got a positive slope of 1. So I'm going to go up 1 over 1, up and to the right, up and to the right, up and to the right. And keep going up and to the right several times. I'm going to draw my line. This one is at y equals negative x, and there's nothing over here. Well, when there's nothing over there, you can always add a plus 0 if that helps you to see that your y-intercept is going to be 0. Adding plus 0 doesn't change the value of the equation. So at y equals plus 0, I'm going to have a slope of negative 1. So I'm going to go down and to the right in a negative direction. So negative over positive, draw the line. That was poorly drawn. There we go, a little bit better. Draw the line, and I can see that they cross right here. And if I go straight up to the x-axis from there, it's at the positive 3. And if I go straight over to the y-axis, negative 3. So the solution to the system of equations is at 3, negative 3.